I would like to welcome our first presenter. It's Ted Mao. Ted is a software engineer at Google, and he's working on various infrastructure level code that we develop at Google, and some cool stuff that he cannot share with you, so he says. But I'm sure if you take him to the side and ask him some probing questions, you'll get some more data. So let's welcome Ted to India and to Hyderabad and to the talk.
Thanks, Sujay. My name is Ted Mao. I'm here visiting from Mountain View, California. It's a little bit jet lagged, but doing all right. Today I'm going to be talking about web testing at Google, and in particular, some of the infrastructure we've built to support web testing. So let me start with a definition. What is web testing? We use the term web testing within Google, but it's not a term that you find widely used in the outside world. We define a web test to be any test that requires like a real web browser to run the test. Not a fake web browser like HTML or something like that, a real web browser. And the type of tests we run using that we consider web tests includes stuff like unit tests, like closure tests or JsUnit, or those kind of tests, and also browser automation style tests, sort of end-to-end tests that use tools like Selenium, WebDriver, Puppet, those sort of things. And these tests typically, test things like web application functionality. Stuff, when you click on a button in your web application, does it respond the way you expect it to? They also are used to test layout and rendering within web applications. Does the application look the way you expect it to in every browser? And finally, these web tests are sometimes used to test performance. Let's say you go to a series of 10 different web pages in a row, or you do a series of actions within your web application. Has the performance regressed since the last time you ran the test? Let me introduce myself a little more and the team that I'm working with. So we have a dedicated web testing infrastructure team at Google, and we work on all sorts of testing infrastructure specifically for web testing. So this includes, things like the test APIs. When you write your test in JavaScript or Java or Python using APIs like WebDriver, Selenium, Closure, JsUnit, etc., we help build those APIs. We also work on the browser automation tools like Selenium and WebDriver, as well as the test runners and all the lower-level infrastructure that integrates with our Google infrastructure to run these tests at scale. The focus of this particular talk will be the bottom three layers. That is the runners. Okay, I'll just keep talking to the mic instead of looking at my slides. Actually, I have a screen up there I can look at as well. The focus of this talk will be the bottom three layers. That is the test runners, the browser providers, and how we set up the test environment. Actually, just to expand on that, there's going to be another talk tomorrow afternoon by Simon Stewart, which will be talking more about the test APIs and browser automation. And in about an hour, there will also be a talk by Nathan York that will focus on some of the more general infrastructure we have for just doing builds at scale, tests at scale, and so on. So what are some of the... these are not my slides. I have to reload. Okay, I think these are out of date. Let me see. Okay. Yeah, that's okay. They're going to be out of order, but this will work. So let me talk a little bit about the history of how we've been running and writing web tests at Google. So in the beginning, we've done it, sort of the most obvious way. If you're a developer, no matter how big your team is, you can run these web tests on your local machine. You run a test, it has access to whatever browsers you have installed on your local machine. For Google employees, that's typically a Linux workstation that has Firefox and Chrome installed on them. And that's fine. But there are problems with this approach. The browsers that you have are limited, though, to those you can access on your local machine. If you're lucky enough to have, more than one machine, then you have access to a larger range of browsers. And also, the parallelism is... Okay, is that better? I was talking to the mic instead of looking at people. Your parallelism is also limited by the fact that you're only running on one machine. There are browsers like, pretty much all the Internet Explorer browsers and Safari that keep global state. So if you try to run more than one test at a time on these browsers, they're going to stomp all over each other. So you're pretty much limited to running one test at a time in serial. There are some browsers like Firefox and Chrome that support the notion of profiles. What that basically means is that they try to keep different profiles. They can run multiple profiles in parallel, and Firefox and Chrome will try to keep these profiles independent of each other. They don't always succeed, so sometimes even then you're going to have tests that stomp on each other. For example, if you have two profiles that download content to the same place on your file system, then they're going to see each other's content. And finally, you have the problem where if you're just running tests on your local machine, then they're not necessarily going to be reproducible on another developer's workstation. This is because of some problems like, whether or not the test passes or not depends not only on the test itself and the version and operating system the browser you're running on, but it might depend on such things as the minor version. Are you running, Firefox 3.6 or 3.6.1.12, etc. They also depend on the configuration of your browser, which might be different from the browsers other people are using. For example, what security level do you have your browser set to? How are you setting your cookies? Are you saving all cookies by default? Are you declaring all cookies after each session? That sort of thing. But at least, if when you're running a test on your local machine, it's pretty easy to tell what's going on. You can see the browser window as your test is running, and you can stick in breakpoints into the JavaScript or the test itself, and you can use debugging tools like Firebug or the Chrome Inspector to really get an idea into the nitty-gritty details of what the browser state is. So how do we try to solve these problems? Like many of you, we try to decouple the test from the browsers that the test has access to. So the first approach we tried was to build a service that we're calling it here a farm, which is backed by a bunch of machines, each one that supports a certain set of configurations of browsers. For example, there might be a set of machines that support IE8, another set of machines that support Firefox 4, and so on. So the test is, in this case, the test is still running on your local machine. But when it wants a browser, rather than trying to see what's available on your local machine, it makes a call to what we're calling here the farm front end and says, please give me a handle to, let's say, IE8 and Firefox 4. And then it uses tools like Selenium RC or remote WebDriver to remotely control those web browsers. This has some advantages. You're no longer limited to the browsers available on your local machine. It also helps you by freeing up your local machine resources so that all your local machine has to do is run the test itself rather than a bunch of browsers. It also helps a little bit with determinism. It makes your test more deterministic because everyone is drawing from the same pool of browsers. And if you do this right, all those browsers are configured in the same way. It still has problems. Okay, get another mic. Okay. Oop. Okay. It still has problems. For example, as I said before, there are a bunch of physical machines and each one's configured for a different set of browsers. There's no good way to dynamically load balance between the different browser configurations. You need to have machines for every browser configuration. If someone wants, most of the tests will be running hopefully with the newest browsers, but then you're going to have tests that will want to test, let's say, Google Web Search against Firefox 1.5, just because we want Google Web Search to work with every browser, and there is some minuscule set of users that are actually still using Firefox 1.5, or IE4, or Netscape 3, or whatever. Okay. The problem is that it's really hard to predict ahead of time how many of each browser configuration you get to keep on hand. You also still have the problem that the test is still running on your local machine, and it's going to be a bottleneck, especially for these large integration-style tests where you might have multiple servers running, databases, etc. Okay. Another problem is that even though if you have different developers running tests, they're sharing the same set of browsers. These browsers could accumulate state over time. We wrote a bunch of cleanup scripts that we attempt to run after each test run to say, clean up the cache, clean up the history, set all the configuration of the browser to be what we expect it to be. But doesn't quite work that well, primarily because we can't, ask whether or not two machines have equal state. And actually, if we did, it'd fail because they obviously would not have equal state. It's really hard to compare the state of two browsers. And finally, we've made the problem of debuggability worse because these browsers are no longer running on your local machine. They're now running in a cloud somewhere else, and you can't really. It's harder to debug them. We might be able to open a VNC session or something like that to the browser, but it's just not as convenient as being able to have the browser on your local machine. And we tried to fix this for a while just by collecting data to figure out what set of browsers how many of each browser to make available on this farm. We also try to improve the robustness of this farm by increasing the sophistication of our cleanup and monitoring scripts. After we would try to continue cleaning up the browser state for a while, and then if it failed for some reason, maybe we put the browser in an inconsistent state because we're trying to clean up the history while it was reading the history, something like that. Then we could just restart the machine, and that worked better, but it still wasn't quite good. The web tests were still flaky. This is what it looked like after adding all those monitoring processes. Like the previous diagram, the left side is the same, but what's changed is the right side in the cloud. We've added more, I would add a little monitoring box under each browser to show that we're adding complexity, more state in there, more monitoring. So like I said, the same problems still apply even after adding these improvements. For example, the test is still running a bottleneck because it's running on your local machine. And each test wants a clean browser environment. It doesn't really know whether it's getting one, and sometimes it's not. Previous tests may have affected the browser in such a way that subsequent tests will get affected and fail for some reason that's not reproducible. So, we tried another approach, and it worked a little bit better. So to solve the problem of the test itself being a bottleneck, we introduced this concept called test sharding. And I'm going to have to gloss over this a little bit because we don't have that much time. But essentially the way it works is that if you have a test suite with, let's say, 100 tests, and you shard your test suite 5 ways, okay, then what you actually have is 5 different machines running how many different ways did I say? So if you shard it 5 ways, and you have 5 different machines running 1/5 of the test each, okay? And then if you add on to the other dimension of browsers, let's say you want to run M browsers. So each of those 5 shards would then be running, so rather than having 5 shards, you would actually have 5 times M shards, and each one of those shards would be running with one browser. Maybe that wasn't a very good example. So, in the slide it says, you shard it N ways on M browsers, you get N times M shards total. If we have time near the end, I'll go over this some more. But essentially, it's a way to increase parallelism by moving not just the browsers to the cloud, but also the tests as well. Okay, and doing this actually opened up some more options for us. If we decide, well, each test wants its own clean browser, right? Each test will want a browser that has no state created by test before it. So why don't we have each test go ahead and create its own browser? This might be done by starting up a VM image from a saved state. This might be done by starting what we call a hermetic binary, which is pretty much a statically linked binary in a well-known state. But anyway, give each shard its own browser. And this actually worked really well for us. So then what we have after doing this is that the test runner, so the test is no longer running on your local machine, but it still has to kick off all the tests. So what it does is says, okay, I want to run these tests. I want to shard it n ways and run it on each test on m browsers. We push the test as well as all its dependencies into the cloud, run the test, and that's how it worked. So how did this help? This really helped us scale because even though it has to start its own browser, the fact that we can parallelize these test runs made them run a lot faster. For example, rather than having one test on your local machine run, let's say, 100 tests in serial, now we have, let's say, if we start it 20 ways, we have 20 different machines, each running 5 tests, and that actually made the wall time a lot faster. It also freed up the local machine resources so that rather than, so that you could do other work while you're waiting for your test to run, or play, some Minesweeper or something like that. And finally, it really improved the determinism because every shard is guaranteed to get a completely clean browser, untouched by anyone else. They still fail if, your test started creating state and affected tests after them in the same shard, but at least someone else's test won't affect yours. However, we still have the problem of debuggability. Not only are we moving the browsers to the cloud, now we're also moving the tests to the cloud. And therefore, all the outputs from the test, log outputs, any display, etc., are no longer on your local machine. Well, we solved the debugging problem in 2 different ways. One was we realized that there are 2 different ways people actually typically run their tests. One is sort of a batch mode, where they try to run all their tests as fast as possible and see which ones break. Okay. Then, in that mode, they don't really care to see the display of the test, but they do want the output of the test after it's done if it breaks. There's a second mode that people run in, which is that if they're developing a new test, or they want to debug a test that just broke, they just want to run one test. Okay. In that case, we don't need all the availability. We don't need to run tests in the cloud. As long as the test on your local machine still has the ability to create a browser in the same way as the test running in the cloud, then it should be deterministic and reproducible in the same way. For the other problem of, what happens to all these outputs when the tests are run in the cloud, we built some infrastructure around that to basically aggregate outputs. This is an example, I guess it's hard to see here, but what's going on is that each row is one shard of one test. And the ones that failed are in red, the ones that are green and passed. And the long list on the bottom half of this screenshot shows that, the last test suite was actually sharded, let's see how much, 15 ways. And even though each shard took between 1 and 2 minutes, so for a total of about 17 minutes for the entire test suite, the wall time was actually 2.5 minutes, which is basically the max of all the wall times of the shards. And I'm not showing it in the slide, but essentially you can drill down to a particular shard to look at the tests run on that shard, the log output from that shard, and so on. So that's our current system. We have a test runner that we're usually running on your local machine. We also have continuous integration and so on. So the tests aren't necessarily kicked off by your local machine. The tests themselves are run in the cloud, in the sharded system, and the output's all aggregated at the end of the test run so that you can view it in a nice web UI. So how well does this actually work today? So what we've accomplished is we run Selenium, WebDriver, JsUnit, Clojure, Puppet, JS Test Driver tests, and more actually, but those are the ones that people know about because those are the open source frameworks that we write tests with. We run a little bit over 1 million tests per day, and we have about over 1,000. We can support over 1,000 concurrent browser sessions. So what this means that if you have 100 tests that you want to run in parallel, and you want each one to run in 10 browsers, we can actually run all those tests at the same time. We also have continuous integration so that when you check in a change that affects one of these tests, all the tests that are affected automatically get kicked off. We've done a pretty good job of creating a deterministic test environment, and one of the side effects of having a deterministic test environment and test in the cloud is that you can actually do pretty efficient test caching. If you and another user happen to run the same set of tests, against the same browser, our infrastructure will actually only run those once. It will run your tests, and if someone else tries to run the exact same tests against the same browsers, it'll just say, those passed or succeeded. We know that because the previous person ran those same tests, and they passed or succeeded. Okay. And finally, we've done a pretty good job of aggregating all of our log output and other test output to a central system. So, we still have some challenges. We still have some future plans. Actually, this web testing infrastructure team that I'm part of has only been active for about a year now. Prior to that, we kind of built infrastructure in small silos. Each product had built their own infrastructure. And although that worked, it wasn't a good use of our time. What we want to do now is we want to scale, of course. That means more browsers. Right now, we support most of the Windows browsers and Linux browsers and some Mac browsers. We want to add on, more. We want to add on mobile browsers, Android, iPhone, BlackBerry. We want to, add on new versions of every browser. This quarter, we're probably adding Firefox 4, IE9, and so on. And we want to scale our capacity as well. Probably, we're on track for about 2x capacity every quarter for about at least for the next quarter or two. And of course, we want these tests to run faster. Right now, we have a problem where, doing stuff like starting a virtual machine for every test shard is kind of expensive. If you start from what we call a VM snapshot, it can take maybe 3 to 5 seconds to start up the VM. And then if you want to run a particular version of Chrome, we have to upload that version of Chrome into the VM and so on. So all that test setup time can take 20 to 30 seconds. If your tests are like big Selenium tests that take a minute or two, it's probably not a problem. If your tests are unit tests that run very quickly, we really don't want to have that kind of overhead. Another point I want to build on is that we really need to improve the conceptual model that our users have of our infrastructure. In addition to building this infrastructure, we support it, and the engineers at Google who are really brilliant, they don't always know what's going on, so they'll attribute blame for a test failure to all sorts of strange things. We really need to help them understand, where the failures in the tests are happening. Are they happening in their tests? Are they happening in the infrastructure? If so, in the infrastructure, which part of the infrastructure, and what they should do about it. Developers are users also, and they can get confused just as other users do. We also really want to measure everything we do. So, what does this mean? We want to know how many of each type of test is running, how long an average test takes, who's running these tests, all that sort of stuff. Because if we don't measure it, we can't quantifiably improve it. I think that's about all I wanted to say today. We have 2 minutes. Any questions? Is there a mic? And I see Bangalore's over there too. I'm not sure if Bangalore has a mic. If anyone wants to ask a question, you can just raise your hand, and I think the mic will come to you. There we go.
Hi.
Whoa.
Hi, this is Vinod. My question is, given that you have a very complex infrastructure, what's the reliability of that infrastructure for running these test cases? Like 99 point something or much lower?
It depends on how you're measuring the reliability, of course. But it's such that we want the reliability to be such that when the user's test fails, they don't blame the infrastructure first. If the infrastructure failing is kind of we want to be an edge case where, first the users will look at their test first and see whether it fails, and only then might look into the infrastructure as a failure point. The only reason why we can actually build such stable infrastructure is because we depend on a lot of other Google infrastructure, Google's production infrastructure that we already use to host all of our web applications. The same structure is the one we use to compile all of these tests that we run, compile all of our binaries, and so on. So, one of the reasons we haven't open sourced this kind of structure or exposed it at all is because we don't think it'd be very useful to the outside world. It's pretty heavily integrated into Google's internal infrastructure that we use for our production services.
Hi, this is Narsingh Acharya. How do you do a stress testing if the number of users is more than 10,000 and with different browsers and different environments settings and with different operating systems? So how do you do the stress testing?
I'm sorry, actually I didn't understand that. Could you say that again?
With different setups, different operating system, and different machine and environments, how do you do the stress testing of the browser?
How you do stress testing?
Yeah.
So what are you stress testing? The application?
Yeah, Google, the search engine.
Okay, so what we found is that using web browsers to do stress testing actually isn't that useful, because what real web browsers are useful for is testing functional interactions between the browser and the application. Unless the browser has a funny bug in which it puts more stress on the application than we would expect, it should be sufficient to just do a stress test where you make HTTP calls to the web application as if it were a web browser. Because we don't really care about the browser's actual functionality, right? We're just trying to stress the application itself. In that case, it shouldn't matter what web browser you're using. Go ahead.
Hi, this is Ruturaj here. I have a question about are you storing the results of the test execution in some sort of database and doing some analysis on what were the major reasons because of which tests were failing, and then trying to see if that test failures can be reduced? Like in my case, I seen that environmental failures tends to be more as compared to the application issues or other issues. Yeah.
Yeah. So as you saw in one of the slides, we are storing all of the test results, and we do a lot of analysis on these results. Actually, for example, we can predict, what the flakiness of a particular test is compared to other similar tests. We can do based on the stack traces of if there's exceptions or test failures. Where are these failures happening? Are they happening in the infrastructure? Are they happening in the test itself? After a major release, do they get more common? Do they get less common, and so on? We're still building a lot of the infrastructure for the UIs for users to be able to see this data we're collecting, to expose this data and make it useful. But we have all the data stored to be able to do that. I don't know where the mic was. But...
Hi, this is Bharat here from National Instruments. I want to know one thing about profiling. Do you do any code coverage profiling when you do these tests? Or if you do, what are the ways you incur?
We have the ability to do code coverage while running these tests. And so when I say code coverage, I mean application JavaScript code coverage. If you are talking about, there's different code, right? There is the test code itself, the code that's making actions in that's telling the browser what to do, and making assertions about the state of the code under test, and so on. So there's that kind of code coverage. And if you wrote like a Java WebDriver Selenium test, you'd use the typical Java tools for doing that kind of code coverage. If you're talking about the JavaScript code running in the browser itself, we also have the ability to do that. And the way it's usually done is by instrumenting the code that's running inside the browser and making it part of the test result that we then, export to the output aggregator with everything else.
Usually, what kind of code coverage you do? I mean, is it functional coverage or any decision coverage? Which is the high priority coverage you do?
And that's not my area of expertise, actually. I just build the infrastructure that allows people to do code coverage, and I don't really know what they do with it.
Thank you.
Question in Hyderabad, the last question.
Okay.
A question. How do you distribute here? How do you distribute the load across the browsers? And do you ensure that each browser gets like 100% coverage of the application? And alternatively, we could not have done by just replicating the browser on the cloud. Like we could have created multiple instances of the same browsers and loaded it. Would that not be a simpler rather than creating a shared? So what is the advantage of this over that? That is it.
So what was the first question again?
The first question was that do you ensure 100% coverage of for each browser, or it does not matter to you?
So when you say 100% coverage, do you mean that we support every web browser? No. Oh, I see what you're saying. Okay.
Functionality is tested against each browser.
I see. No, we don't really. So the application teams themselves are responsible for choosing which web browsers they want to test against. We merely provide the infrastructure that says if you want to test against a certain browser, you can. We have teams that build internal applications, and they know that all they really have to test against is Firefox and Chrome because that's what we use internally. There are externally really facing product teams that will say, well, we only support the latest, some of the latest browsers, and those are the ones we're going to test against. And there are teams like Google Web Search, which says we want to test against every possible browser we can. Oops, that's not my laptop. I can't log in there. Should I finish up there? I know there was a second question.
I think while we log back in, I think why don't we wait for the questions at the end because we have a tight schedule at that point. So I wanted to thank Ted for the talk and for all the insights. So thank you.